All right, you guys. So last class we had that extra day, so we reviewed factoring. Today we are going to be doing a lot of factoring with what our goal is for today. So let's review and factor these two. And so looking with factoring, there's always I don't know if we really talked about it last time. We just kind of jumped into factoring. I want everybody to start getting into the habit of recognizing and asking yourself a couple questions with factoring. Your first question is there a what? What should you always look for first? Good. Is there a common factor? Do I have a common factor here? No. Second question after you've looked for a GCF is how many terms do you have? 3. So if I have 3 terms, I'm like, okay, this is a trinomial. With a trinomial, I really want to check in. Do I have an a value of 1 or an a value greater than 1? Greater than 1, which means I might have a little extra step, extra work to do here. So let's hear from you guys at our front table near my desk. What might you think about after you ask all those questions? What might you think about doing next? What might you guys think about doing next after we've gone through those kind of questions?
A times C.
Good job, Morgan. So I might think about A times C. That's going to go up top in my X, which is 4. What goes in the bottom of our X?
B.
Great, which is -5 here. So I'm looking for 2 numbers that are going to multiply to 4 and add to -5. And what were those 2 numbers?
-1 and -5.
Good job, -1 and -5. And if you have a hard time coming up with those, all right, guys, let's focus in. Thank you. So if you have a hard time coming up with those, just always start with 1, then 2, then 3, and kind of keep going up from there. So I know, and I wrote -5, but it's -4. So I know thinking about your B term is what gets broken down, if that helps you too, with these guys from your X. So that's a -X and a -4X. Our B term gets broken down, and I'm going to bring down everything else. So now that you're here, let's hear from you guys in that back corner table. What are you thinking about doing next?
Finding the greatest common factor.
Good job, Ruby. So I'm going to find that greatest common factor between 2 terms. Remember, I'm creating those groups. So this first 2 and these second 2 groups. And what is the GCF between my first 2 terms? What did you guys see? X. Good job. And then I'll have 2x minus 1 left inside. And what's the greatest common factor between our second 2 terms? What do you guys see? What's the greatest common factor between the second 2 terms?
2. -2.
All right. Morgan, why did you say -2 versus 2?
I said -2 because, it has to be +2, and then, but in the first, expression thing, we said -1. So if you do, -2 times, if you want them to be the same, it has to be just 1 again.
Good. So Morgan was kind of noticing, okay, if I take out a negative, I need this to match, right? And the only way that's going to match is if this value is -2 instead of +2. Because if they match, that means you know you're doing it right, because what's one of our factors going to be? Yeah, 2x minus 1, what's inside? The same thing inside. And what's the other factor? What's our other factor? Good job. What's on the outside? And how could I check to make sure I got this right? What could I do? Yeah, FOIL to multiply back through. All right, let's look at our second example, and let's ask those same questions again. What was our first question? Do we have a greatest common factor? Do I have a greatest common factor in my second example? No, and then I want to notice how many terms do we have, which is 2. So if there are 2 terms, there's something I should always look for. And what is maybe something you notice about these 2 terms? They're both perfect squares. So if I have 2 terms with a minus in between them, and they're both perfect squares, I can do that pattern, the difference of perfect squares. What does the word difference mean? What operation? Difference means subtraction. So it only works with subtraction. And remember that pattern is going to be one of our factors is plus, the other one is minus. And how do I fill in my factors? I take the what of each of these terms? The square root. So it'll be 2x plus 1 and 2x minus 1. And if you did not recognize that pattern, that's okay. You could have factored out the same way. You just would need to know that if I don't see a b value here, like there's no x term, what does that mean my b is equal to? 0. So if you don't see an x term there, just know that means your b term was in fact 0. And still, once again, you can multiply back through to get there. So remember, this only works if I have two terms, a subtraction sign, and they're both perfect squares. What if maybe I had something like 6x squared minus 1? Would that work in that case? No. So can I factor here, right? A times c would be negative 6. So does something multiply to negative 6 and add to 0? Something multiply to negative 6 and add to 0.
Negative 3 and 3.
Do those multiply to negative 6? Not quite. That would be negative 9. See, that's why it works with perfect squares. Is it going to work with negative 6? No. So what do you call something if you can't factor it? Right? There's nothing that, like, I can't think of, like, anything that multiplies to get there. Prime. Good. So this would be an example of something which I would call prime, if you can't factor. All right. So what we're going to do today is we're going to work on intercept form. And we're going to have a lot more factoring to do today. So last time we talked about vertex form. We talked about the transformations. Let's put our computer away if we're not using it productively. Thank you. So we talked about our transformations in vertex form. We talked about graphing in vertex form. What we're going to focus on today is we're going to be maybe given something in standard form and then putting it into intercept form, and then from there finding some graphical characteristics and graphing it. How might you predict you would go from standard form to intercept form? What does intercept form look like? Looks like what? It looks like it was factored, so Vivian is so right. We are going to go from standard form to intercept form by factoring. Noticing here our a value with standard form is still the same a value all the way out there. So that means that's like your factor if it was stretched or compressed or had a reflection. That a is going to tell us that when we are in our intercept form. So let's just make a prediction. If it's called intercept form, what do you think intercept form also will tell us? The intercepts, you got it. So we'll see more about that in a minute. So we're going to first start off by writing these in intercept form. What did we just say? How can I go from this original kind of trinomial standard form into intercept form? If I want to get into intercept form, what does that mean I'm going to have to do? Factor. So why don't you guys take a minute and factor these two? We're wrapping up, so let's go through these two. And where did we go? So let's hear from you guys in that back middle table. What are some ideas you have with factoring our first problem? What's always our first question? Do we have a greatest common factor here? No, then notice I have 1, 2, 3 terms. And then what about my a value? What do you notice about the a value? It's above 1. Good. So then what about you guys on back middle table after going through those questions? What are we thinking about next to factor? Do you guys have any thoughts on how to factor from there? Good job, Cameron. And that was going to be 6. And then what else are you thinking about? Good job, B under, which is 7. So what multiplies to give us 6 and adds to 7?
6 and 1.
Great job. So remember using those two to break up that, remember, break up B. So this is going to be plus 6x plus 1x, or just x plus 3. And then now you guys in our from middle table, once we have our 4 terms, what are we thinking about from there? How can I factor once I have my 4 terms? What are you guys thinking about? Because remember, once you have 4 terms, how might you kind of put them together and help keep factoring? Do you want to help them out, Luna? What do you do?
The greatest common factor.
Good job. The greatest common factor between the first two, which we know is going to be 2x, and then we'll have x plus 3. And then what's our greatest common factor between our last 2 terms?
1.
1. Awesome job. So remember, that's positive, so plus 1, and then we'll have x plus 3. So are we factoring right so far?
Yeah.
How do I know? What do I see? What do I see to kind of cue me that I'm doing this right?
Values in the parentheses are the same.
Good job. Those values in the parentheses are the same of x plus 3, so I know one factor is x plus 3, and what's our other factor? Good job. 2x plus 1. All right, let's look at our second example. And going through those questions, do we have a greatest common factor? No. How many terms do we have? 3. So then look at my a value. Is my a value 1 or bigger than 1? Bigger than 1. So that is going to be kind of that grouping to help us get there. So now I'm thinking about, what am I thinking about next? You guys up in the front table to help us keep factoring. Okay, what multiplies to negative 24, and what else do we have to do? And what were those 2 numbers?
-3 and positive 8.
Good job. -3 and positive 8. So we're using that to break up our B and bringing everything else down. And now that we have our 1, 2, 3, 4 terms, we're going to group from here. So you guys in our middle or back corner table, what was our greatest common factor between those first 2 terms? Good job, 3x. And if you had your values switched around, yours might look a little different, but you should get the same factors in the end. And then you'll have 2x minus 1. And then what's our GCF between our last 2 values? What do you guys see? Good job, positive 4, so plus 4. And both my parenthesis terms are the same, so I know I'm doing it right. So one factor is 2x minus 1, and what is our other factor? Great job, 3x plus 4. So here's what I want you guys to understand from here. Are both of those in intercept form? Like, did I factor both of them? Yes, both of them are in intercept form. Remember, you factor to get into intercept form. But intercept form could also look a little different. It could have looked like a times x minus p and x minus q. Meaning, inside my factors, I only want the coefficient in front of x to just be 1. So looking at our first example here, my second factor looks good, right? I have x plus 3, so just that coefficient there is 1. Over here I have 2x plus 1. So, kind of thinking about, like, if I want this just to be 1 right here, I would have had to factor out what values in here. 2, so kind of think about, I'm like undoing the distributive property by factoring out a 2 here, and I would be left with x plus what? 2 times what would have given me back 1? Yeah, 1/2. So if you have a hard time kind of getting from here to here, just think about, I got to divide both by that coefficient in front of x. And then think about, if I divided, I also have to multiply, which means that's going to be that factor I'm multiplying by out there to kind of get me back to that same equivalent expression. And then I'll still have x plus 3. So now that looks like that form from Intercept Form. So we might prefer to have it in this setup because it's really easy to see our intercepts in that form. But just know that this is okay with me too if you're ever asked to write something in Intercept Form. As long as you're in factored form, that's good for Intercept Form for me. But let's look at this next example. How could you get there too? So notice both. We'll have to do this twice. So kind of think about, here I have 3x plus 4. If I want just this to be 1, so just x, what would I need to factor out from that?
3.
Yes, 3. So I'm going to have to factor out 3. Then it'll be x plus what value?
4/3.
4/3. Think about it, you divided it by 3. That's what it means to factor out, right? Divide by. Instead of distribute, multiply it to their opposites. So next with this factor, if I have 2x minus 1, what value do I want to factor out? 2. So now I'm going to have 2 times 3 all the way out front. And then I'd have x minus what value? 1/2. So think about, my a value is going to end up being 6. And is that the same a value from my original problem? Good, that's like a good check. So like you guys said before, it's going to be really easy when you're in this setup to find your intercepts. But if you wanted to kind of keep it in that like line before, you can still find your intercepts there. You just might have an extra step to find your intercept. So let's see, what other questions do you guys have here? All right, so we know our a value is still the same. That dilation factor, so it'll stretch, compress, and it can also reflect over your x-axis. But your x-intercepts are going to be super helpful with these factors to find those values. So thinking about kind of this generic setup here, how do I algebraically find x-intercepts? How do I find x-intercepts algebraically? Can I think about that same process no matter what our function is going to be? Good job, Liam. So instead of y, it's now 0. So I'm going to have a times x minus p times x minus q, where p and q are just a, p and q are just some numbers, right? So now think about solving for x from here. I could divide both sides by a. And what's going to happen if I do 0 divided by a? That's just going to give us back what? Just 0. So I'm going to end up with 0 equals x minus p times x minus q. So think about what this equation says. It says 0 equals something times something else. So for what kind of is that scenario? If something times something else equals 0, what do you know? What do you know, Mithra?
One of the numbers has to be 0.
One of those numbers, or in this case here, one of these factors has to be equal to 0. So we're going to find those two situations, right? We have two values for x, that could occur. So I'm going to have x minus p, that first factor, equals 0. And I'm going to have x minus q also equals 0. Because if this equals 0, or that equals 0. I know I'm going to have 0 times something else, and that's going to give me a y value of 0. So with that, if I solve by adding p to both sides, I'm going to have x equals p. And if I add q to both sides, I'm going to have x equals q. So I would say this was probably our most missed thing on our Unit 2 test. If you were asked for intercepts, you just left it like this, but we always write intercepts as what? Points, ordered pairs, good. So that's how I'm going to get those ordered pairs of p comma 0 and q comma 0 for your intercepts. So I would say x-intercepts, big thing to note. Set y equal to 0, and then you want to set each factor equal to 0 and solve. So you place your y with 0, still that same process we've been doing, and then you're going to make your each factor equal to 0 and then solve for x from there. Some of you guys might be able to just kind of look at it and see, but if not, you can always take that extra step and write it out as well to solve. All right, what questions do you guys have before we try some examples? All right, let's see what we've got going on. All right, why don't you guys take a minute, jot down whatever you need to for the problem, and answer that first question. All right, so looking at our graph, what did you guys see? What are the x-intercepts?
-1, 0, -2.
Great job. Great job saying those as ordered pairs. All right, so how can I take those values for my x-intercepts and write factors? And think about, here's what our factors look like. Number is like x plus or minus of number. So if my intercept's at -1, what would the factor have been? What do you think, Delta? Good job, x plus 1. And then we would have also had x plus 3. How did you know that those were the factors? Oh, good. Kind of thinking about, you know you want it to equal 0, right? So thinking about if x is -1, -1 plus what number would have given me 0? Oh, that would have been plus 1. -3 plus what number would have given me 0? Oh, that would have been plus 3. So y'all just think about that idea of like an additive inverse. So flipping the sign, if you kind of don't know, didn't kind of notice, to get from an x-intercept to a factor, flip your sign. So what is that equation in intercept form? Just because I have the factors, does that mean I have the equation? No, because my equation in intercept form can also have what value? And what value could I still have? I have a big chunk of it for intercept form, but not quite my full equation, right? I still have what factor I could be missing. A is right. So there's an A value here that I need to solve for and I need to find. Looking at your graph, what are some predictions you might be able to make about your A value? What do you think? 2. Maybe you were predicting it's 2. We can for sure predict it's going to be what? Positive or negative? Positive. Y'all just saying, I'm predicting it's going to be 2. How did you make that prediction of 2? Yeah, so remember, instead of slope, we don't think about slope anymore now that we're in our quadratic, right? Slope's for a line because it's constant. But you kind of can see, to get to your next point, you went up 2 over 1. Notice you don't continue with that pattern, but just to get to the next good point. That can kind of help us see that prediction. But let's make sure we solve for it algebraically in case it's a crazy fraction that we're not quite able to recognize. So let's solve for that algebraically. And how can I find my A value algebraically? Something we've done before 2 classes ago. What was that?
So still trying to get to the intercept form.
Awesome job, Evan. So, what's a good point on my graph I could substitute? What do you guys see? What's a good point we have on the graph? Okay, I'm glad you said that, Liam. So Liam said -1, 0, right? One of our intercepts. If you plugged in -1 here, -1 plus 1 would have given us what value? 0. And then I would have had A times 0. Is that going to help me find A? No, so I can't use my intercepts, but I can use any other point. So what's one other good one? What do you see, Sabina?
-2.
Good job. -2, -2. So I'm going to use the point -2, -2 to help us solve for A. So instead of Y, what value am I going to replace it with?
-2.
Good. And instead of X, we'll replace it with?
-2.
Good job. So solving for A from here, I know I would have -2 plus 1 is -1, and then -2 plus 3 is 1. So this is really just negative A, or -1A, equals -2. And then what do I know for sure? What is A? Great job. A is 2, so my equation is for sure going to be Y equals 2 times X plus 1 times X plus 3. And if you want to be double, triple sure, you can always find another good point on your graph. Like it looks like the y-intercepts might be what value? Like it looks like it might be 6, right? So I could think about, okay, well that's the point 0.06. So if I plug in 0, all right, that would be 1, and then that would be 3. 2 times 1 times 3, is that 6? Yeah, so that's like a good check. What's your question, Morgan?
Isn't there like a rule where you can't use like the vertex point?
Oh, I'm glad you brought that up. That was when we were in vertex form. So we didn't use the vertex when we were in vertex form, and we didn't use what when we were in intercept form? Intercepts. So kind of think about what form are you in, and then if you don't recognize it, if you try those points and they give you 0, you're like, oh, well, I just need to try another one.
Okay.
Good point and connection back from last time. Any other questions you guys have? All right, let's try our next problem here. Or actually, before we try our next problem, we have our intercepts, we have our vertex. Does anybody remember another key characteristic when we were talking about quadratics? Okay, 2 classes ago, it was maybe like a new idea. We have our intercepts, we have our vertex. It's this idea that goes right through the vertex.
Axis of symmetry.
Good job, our axis of symmetry. So that vertical line, that's cutting and splitting our quadratic in half. It's kind of mirrored right about there. What would our axis of symmetry be here?
-2.
Good, so I write it as an equation. So it's x equals -2. So let's make a couple connections to this, right? That's the x value for your vertex, kind of where you cut right through. How else maybe might you recognize that and see it if you only know your intercepts? So let's say we don't know the x value for our vertex, we only know the intercepts. How could I find out where my axis of symmetry is going to be? What do you think, Ruby? Good, it's the middle of the two. So let's think if I have 2 things, how do I find the middle of them?
You can open them up and then divide it by 2.
You got it. Find that average. So adding them up and dividing it by 2. So that's going to be how we find our axis of symmetry between our two intercepts. We're going to do exactly what he just said. Add it together, divide by 2. So if I had -1 and -3, right? Those were our intercepts last time. I add them together for -4 and I divide by 2. Notice that gave me -2. So that's going to give you the x value for your vertex. And how do I always find, so think about our problem before, we had -1 plus -3 over 2, which gave us -2. And if I know an x value for any point, right? So this is my x value for my vertex. How can I always find the corresponding y value if I know the x? I can use the function how? How can I find a y value if I know an x? That would just be finding an intercept. But just in general, right? Anytime I want to find the output, I know the x value. How can I find the output? What would I do? Exactly, just plug it into the function. So thinking about here, if I have my x value as -2, that's what this key piece is saying down here. It's saying plug into your function, that's the f, of whatever your x value was from your axis of symmetry. So kind of think about what our equation was from our problem before. It was 2 times x plus 1, so that would have been -2 plus 1, and then x plus 3, which is -2 plus 3. So this would have given us 2 times -1 times 1, which ends up with the y value of -2. So does that make sense? Based off of what our graph looked like? Yeah, that's where we got our vertex at that point. So always go back to that foundation. If you want to find a y, use the x, plug it back in. All right, we only have like maybe 1, 2 more examples. Any other questions here? So I think this is it. Yeah, so why don't you guys take a minute, jot down our equation, and then kind of see what you're noticing from your given equation, and then we'll start jumping into the problem. All right, you guys, so looking at our equation, what are some things you're noticing about our equation? No right or wrong answers, just what are you kind of noticing about that given equation? Anybody have any observations from our equation here? No right or wrong, it's just kind of what you're noticing. What do you see, y'all? Ooh, yes. We have a positive A value, so we know we'll be like kind of that U shape up. All right, that's a good thing to notice. What else do you see? What do you see, Vivian? Ooh, we have a compression going on with that 1/2, so we'll kind of look a little wider. Anything else you guys see? Those are some good connections for what our graph is going to look like, right? So let's think about these characteristics we want to go through. How can I use my equation to find my x-intercepts?
Convert it into equation.
That would be a lot of extra work, huh?
With y is 0.
Yes, I just replaced y with 0. And I set each factor, so basically y becomes 0, right? Which means I just set each factor equal to just set each factor equal to 0. That's all we have to do to find an x-intercept. So, knowing that, if x minus 1, if this whole factor is equal to 0, then I know my output would be 0. The y value would be 0. So what value for x would make that 0?
1.
Good, 1, comma 0 would be my x-intercept. And then what about for my other x-intercept? Good job, negative 3, comma 0. So let's put those 2 points on our graph. All right, we have a quadratic, so we can cross our x-axis up to 2 times. Now, how do I find a y-intercept?
2x for 0.
Good job, substitute x for 0, so y is going to equal 1/2 times 0 minus 1, which is negative 1, and then 0 plus 3, which is 3. So what is that going to give us as an ordered pair?
0, negative 3 over 2.
Good job. So that's going to be negative 1.5 right here. Now let's find our axis of symmetry. So what do we know? Where will our axis of symmetry be in between our intercepts? In the middle. So if you don't even know how to get there, like algebraically, just find the middle. What's the middle between these two?
Negative 1, x equals 1.
Yeah, negative 1. But let's go over how could I find that algebraically. What could I have done? How do we find it algebraically if maybe just seeing that middle wasn't working for you? How do you find the middle?
Add the intercepts together and divide by 2.
Good job. So if I did negative 3 plus 1 divided by 2, that gives me negative 1 for my axis of symmetry. Remember, that's an equation, x equals. So if I know where my axis of symmetry is, I know the x value for my vertex. So my vertex is going to have an x value of what? Negative 1. Good. Now, how can I find the y value there? What would the corresponding y value be there? What do you think, Ruby? Great job. So y is going to be equal to 1/2 times negative 1 minus 1, which would be negative 2, and then negative 1 plus 3, which is 2, which would give us what output for a y value? Not positive 2, but negative 2. So here we have the point negative 1, negative 2. But that makes sense, right? If you maybe like missed a sign and you said positive 2 up here, would that make sense to like get that as my y-intercept too? That wouldn't have made sense, right? There's no way for me to do that and then curve right back. So kind of using those other points to kind of check in and be like, okay, well this is making sense. This looks legit. So how many points do we have? 1, 2, 3, 4. We want a minimum of how many good points? 5. So let's find one more good point. How could we find one more good point? Kind of just some basics. How do we always find more points? Plug in points. Good job. Always go back to that foundation. So what's the x value we want to plug in?
Negative 2.
Negative 2. All right, so if I plug in negative 2 into my function, I'd have 1/2 times negative 3 plus 1, which would give us a y value or an output of negative 3 over 2, which does that make sense with kind of what we got going on? Yeah, because it should be symmetrical. And there's our beautiful graph. I'm kind of checking in with some observations we made from the beginning, right? We have that compression, we have that U-shaped, it's facing up for our A value. Any other questions or things you're wondering about here? All right, so that is our lesson for today with Intercept Form. The main thing to know is when you're in Intercept Form, how do you find your x-intercepts?
Make y.
You make y 0, and then you'll set each factor equal to 0. Good. So keeping that in mind, what you guys are going to work on next is this classwork. I'm going to pass out to a couple copies for each table, and it's the tier questions. So like the first page you get will be the easiest, second page, third page will all increase each time. So after you guys have the first page done, listen to the directions real quick, you guys. Thank you. After you get the first page done, you have two options. You can either ask me to check your work, or if you have your computer up and you want to go to the speaker notes on this slide for today, for slide 12, then you'll find the key like all the way at the bottom. So check one tier at a time, and then when you're ready to move on to the next one, let me know and I'll hand you some papers. So before that